So guys, let's start solving this problem using bottom-up dynamic programming approach. As you have seen in the previous videos as well, that for the bottom-up, we break down the problem into sub-problems by starting with the very base case. For example, here we can see that there are two variables. One is capacity and other is the items that we have with variable weights and values. So we'll start with the very base case that if the from 0 to 15 kg of capacity and for each of the item one by one. We start with the base case in bottom-up approach and we always try to move up to the next level by adding, for example, in this example, we will keep on increasing the capacity and check what's the possible, the best weight possible to the maximum value possible by choosing an item. And we keep on increasing the item like this. And then we will see any pattern which is followed here, or whether we can reuse whatever the values we have already computed in the previous subproblem. So this is the basic of dynamic programming for any problem, not just this problem, but any problem. This is the base case, and we just go with the base case, solve the problem. We see a pattern which is there, and then for the other subproblems, we try to reuse whatever we have computed already. So for knapsack problem, as mentioned, there are two variables. One is the capacity, and other is the number of items that we have. So let me break it down into two grid array. So here in the columns, I will start with capacity 0 to 15. So it would be 0, starting from 0. We will check for each base case one by one, and then similarly, we'll do it for the items as well. So in the columns, I have put all the possible capacities, like starting from 0 kg, 1 kg, up to 15 kg. And similarly, for the items, we'll start whatever the items that we have. We have got 1, 2, 3, 4, 5 items, which will go in the row. So let's start with the first item. I mean, when there is no item, so I mark it as empty, and we'll start one by one. So we'll start with the first item here, which is having value of $4 and weight of 12 kg. So let's fill in for the base condition first that there is no item at all. So for this, if there's no item, then it means that the maximum capacity, the value which we can get with whatever capacity that we have, whether it's 15 kg, 20 kg, or 5 kg, whatever. If we have no item to take away, it means that the maximum value would always be 0 for the base condition. So if the capacity is say 0 kg, it doesn't matter. It would be a 0 or 1, whatever. If we don't have any item to take away in the knapsack bag, the maximum value would always be 0. Now let's choose the first item of $4 and weight 12 kg, right? Here I'm just putting the array index. 0 is for empty and 1 is for the first item. So here, if the capacity is 0, I mean the bag of 0, it means that we can't do anything, right? So the value would be 0. So let me iterate that all these cells that we are doing, this is the maximum value that we have already calculated. And we are trying to calculate in all these cells what is the value associated with for the whole problem. So if I choose one item and I have got a knapsack bag of say 1 kg here in this cell. So because the weight is 12, so 12 kg will not fit into 1 kg knapsack bag, right? So it means that we cannot take this item because the weight overflows for 1 kg bag here. So it means that if you can't carry it, similarly it would be for 2 kg bag, 3 kg bag, because all these bags are having very low capacity because the first item that we have is having a weight of 12 kg. So it means that it would be 0 for all the cells. Now we have got the capacity of 12 kg, right? That bag is of size 12 kg. It can carry 12 kg. So right now it fits. So we can choose this item and place it here. So it means that Now the maximum value would be 4 associated with this item. So it would be 4 here. Now again 13 kg because only we have got one item. So it means that it would be 4 for 14 kg or 15 kg bag as well. So this is for the first item, the base condition that we have selected. Now similarly, we'll go on with the other items. Now for the second item, we have chosen is this one with having value of $2 and weight 1 kg. So let's fill our grid here. Would be, yeah, for 0, it would be 0. Now see, we have got like a 1 kg bag here, and we see that the weight of this second item is 1 kg. So it means that we can have this item. We cannot take first item because first item is too heavy. So we are like, at least we can have the second item and put it into our bag of capacity 1 kg. And the value associated is 2. So it should be 2. Again, it goes same for 2 kg bag, because for 2 kg bag also we can only fit this item. So it would be 2, 2, like this. Now till 11, we can only choose, if the capacity is only 11 kg at this point, we can only fit this second item having weight of 1. Now here when we go to 12 kg weight, right? Now we have again got an option. We can choose either this or this item or both of it. But we see that if you want to include both the items, the weight would be 13 kg, which will be overflowing our capacity. So now we have to choose that what is the, so we have to choose this or this, and we know that the value of this item is 4 and this is 2. So it's better to choose this one because it has got more value. So we take 4 here. So here we have seen like this, that we it's very much similar to what it was before here. So here we are just taking the value which was up from here. And similarly for now 13 kg, right? 13 kg, if we have got 13 kg, now we see that we can fit both the items, 12 and plus 1, 13. It means that if we take both of them, the value would be 6. So here, again for 14 and 15, it would be again 6 because we can choose both the items and carry it in the bag. Now let's go to the third item. Now we have got the third item, which is this $10 and 4 kg. So we have got choice of 3 items, and now we have to see that if we have a capacity of 0, 1, 2, 3, and we have got these three items available, what is the maximum value we can get by choosing one item, or choosing all the items, or not choosing any. So here, the base is 0 because in capacity 0, we can't take anything. Now for 1 kg, right? For if I got a bag of 1 kg and we have got these 3 items available, so only item which can fit here is this one, the second item, because it's weighted 1 kg. So it means that the value here would be 2. Because we already have calculated that whatever is, if we choose here, and if we only have like 2 items, and in this particular cell, we already know that what is the maximum value possible if we have got 2 items, these 2 items, and the capacity of 1 kg. This has been already calculated here in our previous computation for this problem. Now, if we increase the third item, we see that still, because the third item is too heavy for 1 kg bag, and we choose whatever we have already calculated for first 2 items before, which is this cell. So we just copy this from here and here. So the whole idea of this bottom up, as we have seen in the previous problems as well, that we start with these base cases, and then we try to see a pattern which we can follow, or we can deduce an algorithm based on the pattern that we see. So here we see that we just copy this value from up to the bottom if we are not choosing this item. If we are not choosing this item, we already know that for these 2 items, we have already calculated the max value here before. So this is the scenario when we don't just choose this item, we just copy the value which is up into this cell. Similarly for 2 kg, because we are not going to choose this item, so we choose whatever was the previous solution for these 2 items, which is this cell. We copy this here. Similarly, for 3 kg, it's still up because 3 kg is less for this. Now for 4 kg, right? For if we have a bag of 4 kg here, now the things get interesting. Now we can fit on this item as well. And we know that for the previous, if we only have like 2 items and the bag of capacity 4 kg, this was the maximum value possible. So either this is this option, or if I include this item as well, the third item, then I have to choose that which item I can remove, or which item we can choose to get the maximum value possible. So here we can see that the previous is 2, and if I just choose this item and discard these 2 items, the value would be 10. 10 is more than 2, so I will choose 10 here. Now for bag of having capacity 5 kgs, now we have to check again that, okay, this is the value which is just above it. This is the maximum value possible when we have these 2 items only of 5 kg. So we get the maximum value of 2. Now once we include this third item, we see that if we can include this item, or whether the value will increase more than 2, or if we just take the value by excluding this item. So let's compare this. So we see that we can fit both second and third item, because 4 plus 5 would be 5 kg. So it means that we can include both the items. So it would be 10 plus 2, 12.